Welcome back, mathematicians. Today we're talking about scientific notation, and this is found on page 34 of your textbook. Well, why do we use scientific notation? We use scientific notation for very large or very small numbers. This is the number of stars in the Milky Way. That's quite a huge number, and if you don't remember how to read and write numbers, it is quite difficult to get an idea. So let's just revise reading our number. This was the group of ones. This was the group of thousands. This was the group of millions. And that was the group of billions. So we have 200 billion stars in the Milky Way. Right, we're going to use an easier example to explain scientific notation and then come back to that. Let's use the number 1,400,000. The ones, thousands, millions. 1,400,000. Well, we use the laws of exponents to write large numbers in scientific notation. We have got 1,4 million, and a million can be written like that. So 1,400,000 can be written as 1,4 times 1 million. But we know that 1 million can be written as 10 multiplied by 10 multiplied by 10 multiplied by 10. 1, 2, 3, 4, 5, 6. So this is 1,4 multiplied by 6 tens multiplied together. So if we write this in scientific notation, it will be 1,4 multiplied by 10 to the power of 6. There were 6 zeros there, so therefore you have 10 to the power of 6. Another way of looking at it, to write scientific notation, you always have one significant digit. So a significant digit is a 1, 2, 3, 4, 5, 6, 7, 8, or 9. A 0 is not a significant digit. So we have one significant digit, 1,4. If I put my comma here, my number hasn't changed its value. And the comma is going to move 1, 2, 3, 4, 5, 6 places to the left, multiplied by 10 to the 6. Let's go back to your 200 billion. So the first thing we do is we put a comma at the end of the number. We know we need one significant digit, so this in scientific notation is going to be 2,0 multiplied by 10. How many places does the comma move to the left? Well, that's 3, 6, 9, 10, 11. 2,0 times 10 to the 11. Let's look at the worked examples. The first one, you asked to write 32 million. Remember, these are the group of ones, thousands, millions. So 32 million, written in scientific notation, we would have put the comma at the end. It must have one significant digit, 3 comma. So that's 3 comma 2. How many places did the comma move? 3, 6, 7. So it's going to be multiplied by 10 to the 7. Right, let's look at number 2. Write 3,59 times 10 to the 9. Well, the first thing we're going to do is we're going to write 3,59, and we're going to add a whole lot of zeros. Have I changed the value of the number? No, because zeros on this side of the comma are meaningless. Right, this comma must move 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, So that will be my number, right? And we write numbers in groups of threes. So this, in decimal notation or ordinary notation, is 3590, and then we've got another two groups of 3 zeros. How do we say that number? Well, those are the ones, those are the thousands, those are the millions, these are the billions. 3,590,000,000. Example number 3. The Earth is 150 million kilometers from the Sun. Write this distance in scientific notation. Well, the first thing we're going to do is we are going to write 150 million in digits only. Remember, we had our million, thousands, and our ones. So 150 million, they are whole millions, so it's written like that. Thousands we fill up with zeros, and the ones we fill up with zeros. So 150 million is written like that. Scientific notation requires that we have one digit in front of the comma, one significant digit in front of the comma. So the answer here is going to be 1,5 multiplied by 10. The comma would have moved from here. How many places? 3, 6, 7, 8. So that would be 1,5 times 10 to the 8. That's all for scientific notation. You will find more examples to practice in the apply exercise on